Well, welcome back to our course on system engineering. Today, we're going to be going over chapter 3. And so we'll be talking about agile software development. And so the 4 topics that we'll be focusing on here are agile methods, agile development techniques, agile project management, and scaling agile methods. So in terms of rapid software development, rapid development and delivery is now often the most important requirement for software systems. Business operate in a fast changing requirements operate in a fast environment. So in changing requirements, and it's practically impossible to produce a set of stable software requirements. Software has evolved quickly to reflect changing business needs. And so plan-driven development is essential for some types of systems, but does not meet these business needs. As a result, agile development methods emerged in the late 1990s, whose aim was to radically reduce the delivery time for working software systems. So you can have little sprints or things like that you can be doing in incremental developments. So for agile development, you have program specification, design, and implementations. These are all interleaved. The system is developed as a series of versions or increments with stakeholders involved in the version specification and evaluation. There's frequent deliveries of new versions for evaluation, and there's extensive tool support, that is automated testing of tools used to support the development. There's minimal documentation that focuses on getting the code working. So here's a comparison between plan-driven versus agile-driven. So in plan-driven, it's a more of a linear process. You have requirement engineering going to requirement specification and then going to design and implementation. You can be iterating with the requirements. You can be iterating with a design and implementation. And as you uncover things in design and implementation, things can be folding back into the requirements. That is in comparison with agile development, that's just sort of this loop that you have requirements, you do design, and those design feeds back into the requirements. It goes back and forth, back and forth, back and forth. And so this is, you don't have the specifications as much as an active role in that. So how do we compare these two? For plan-driven development, a plan-driven approach to software engineering is based around separate development stages, and the output to be produced at each of these stages planned in advance. It's not necessarily a waterfall model. Plan-driven and incremental development is possible, and iterations occurs within the activity. So that would be the one approach, and the other one is now this agile development, where the specification, design, implementation, and test are interleaved, and the outputs from the development processes are decided through a process of negotiation during the software development process. So let's talk about the agile methods in terms of why is this here? The dissatisfaction with the overheads involved with software design methods in the 80s and 90s led to the creation of agile methods. These methods focus on the code rather than the design. They're based on the iterative approach to software development. They're intended to deliver working software quickly and evolve these quickly to meet changing requirements. The aim of agile developments, agile methods, is to reduce overhead in the software process by limiting documentation and to be able to work quickly to changing requirements without excessive rework. So in terms of an agile manifesto, so what is it that we would want to be focused on? We are uncovering better ways of developing software by doing it and helping others do it. Through this work, we have come to value individual and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a plan. That is, while there is value in the items on the right, we value the items on the left more. So just think about that, you know, here are the things that you want to be focusing on. So the principles of Agile methods. So we have customer involvement, incremental delivery. You want to be focusing on people, not process. You want to be able to embrace change and then maintain simplicity. So the customer should be closely involved throughout the development process. Their role is to provide and prioritize new system requirements. And they're going to be, you always want to make sure you have the voice of the customer. Incremental delivery, the delivery is developed in increments and the customer specifies the requirements to be included in each increment. You want to be focusing on the people. The skill of the development team should be recognized and exploited. Team members should be left to develop their own ways of working without prescriptive processes. In terms of embracing change, you want to expect the system requirements to change, so design the system to accommodate these changes. And in terms of maintaining simplicity, you want to focus on simplicity in both the software being developed and the development process. Wherever possible, actively work to eliminate complexity from the system. So when and where would Agile methods be applicable? Product development, where a software company is developing a small or medium-sized product for sale, this would be a good example. Virtually all software products and apps are now developed using an Agile approach. Custom system development within an organization where there is a clear commitment from the customer to become involved in the development process and where there are a few external rules and regulations that affect the software. So now let's focus on the Agile development techniques. There's a term called extreme programming, a very influential Agile method developed in the late 90s that introduced a range of Agile development techniques. Is something called extreme program, or XP, that takes an extreme approach to iterative development. New versions may be built several times per day. Increments and deliveries to customers could be every 2 weeks, and all tests must be run for every build, and the build is only accepted if tests run successfully. So here is the extreme process release cycle. And so you select user stories for this release. And so what kind of capability does it have? You break the stories into tasks. You plan the release and develop and iterate the test software. You release it, and then you evaluate the systems. Then you go back and forth. So what are the user stories that's going to be in each of these planned releases? That's the focus there. So here are a couple charts focusing on the practices associated with extreme programming. So you want to have incremental planning, you have small releases, simple design. You want to have test first development and a refactoring. So the requirements are recorded on story cards, and the stories to be included in the release are determined by the time available and their relative priority. The development breaks these stories into development tasks. So you want to focus on small release. The minimal useful set of functionality that provides business value is developed first. Releases of the system are frequent and incrementally add functionality to the first release. You want to be thinking in terms of a simple design. Enough design is carried out to meet the current requirements and no more. So focus on those steps that are near term and high value. You want to have a test first development. Automated unit test framework is used to write tests for a new piece of functionality before the functionality itself is implemented. Refactoring. All developers are expected to refactor the code continuously as soon as possible. Code improvements are found. This keeps the code simple and maintainable. Continuing on, there are a couple other things, pair programming, collective ownership, continuous integration, sustainable pace, and on-site customer. These are also things. So for pair programming, developing in pairs, checking each other's work and providing the support is always a good way to go forward. Collective ownership, the pairs of developers work on an area of the system so that no islands of expertise develop and all the developers take responsibility for all of the code. Anyone can change anything. So in terms of continuous integration, as soon as the work on a task is completed, it's integrated into the whole system. And after such integration, all the unit tests in the system must pass. For a sustainable pace, large amounts of overtime are not considered acceptable, as the net effect is often to reduce quote code quality and medium-term productivity. So a continuous, sustainable pace is a much better approach. It makes more sense to have an on-site customer, a representative of the end user of the system should be available full-time for the use of the extreme programming team. In an extreme programming process, the customer is a member of the development team and is responsible for bringing system requirements to the team for implementation. Okay, well, let's talk about extreme programming and agile principles. The incremental development is supported through small, frequent system releases. Customer involvement means full-time customer engagement within the team. People, not process, through pair programming, collective ownership, and a process that avoids long working hours. So you want to make it in a constant stream of good work. Change needs to be supported through regular system releases, and the maintaining simplicity through constant refactoring the code should be the focus that we have. What are the influential extreme programming practices? Extreme programming has a technical focus that is not easy to integrate with management practices in most organizations. Consequently, while agile development uses practices from extreme programming, the methods as originally defined is not widely used. So the key practices are use user stories for specification, be open to refactoring, test first programming, and then pair programming. Those are the things that are good focus areas. So you want to be using user stories for requirements. So in extreme programming, a customer or user is a part of the extreme programming team and is responsible for making decisions on requirements. The user requirements are expressed as user stories or scenarios. So that's a good way to be thinking about. These are written on cards, and the development team breaks them down into implementation tasks. These tasks are the basis of schedule and cost estimates. A customer chooses a stories for inclusion in the next release based on the priorities and the schedule estimates. So here is, I won't read this, but here is a prescribing medication story that can maybe give you an example of how this could be played out. And here's some examples of task cards for prescribing medication. So task 1 is change the dose of the prescribed drug. 2, formulary selection, and task 3 is dose checking. So here are some things that you would be thinking about. Maybe you just code one of these at a time and have releases as you go. Now let's talk about refactoring. So conventional wisdom in software engineering is designed for change. It is worth spending time and effort anticipating changes as the release reduces. This reduces costs later in the life cycle. Extreme programming, however, maintains that this is not worthwhile as changes cannot be reliably anticipated. Rather, it proposes constant code improvements, that is refactoring, to make changes easier when they have to be implemented. Programming teams look for possible software improvements and make these improvements even when there is no immediate need for them. This improves the understandability of the software and so reduces the need for document changes. Changes are easier to make because the code is well structured and clear. However, some changes require architecture refactoring. This is much more expensive. So what are some examples of refactoring? Say you have a reorganization of a class hierarchy to remove duplicate code, so that would require refactoring. Tidying up, renaming attributes and methods to make them easier to understand, or the replacement of inline code with calls to methods that have been included in a program library. So you can be simplifying it and increasing the use of program libraries. So what about test first development? Testing is central to extreme programming, and extreme program has developed an approach where the program is after every change has been made. Extreme programming testing features. Here's a couple items. First, you think about test first development, and then the incremental test development from scenarios. You can focus on that. User involvement in test development and validation, that's an important thing. And using automated test harnesses to run all component test each time that a new release is built. So you have a standard set of tests that you make sure that things are working before you release the next version. In terms of test-driven development, writing tests before code clarifies the requirements to be implemented. Tests are written as programs rather than data so that they can be executed automatically. The test includes a check that has executed correctly. Usually it relies on a testing framework of some sort. All previous and new tests are run automatically when new functionality is added, thus checking that the new functionality has not introduced errors. Customer involvement is always important. The role of the customer in the testing process is to help develop acceptance tests for the stories that are to be implemented in the next release of the system. The customer who is part of the team writes tests as development proceeds. All new code is therefore validated to ensure that it is what the customer needs. However, people adopting the customer role have limited time available and so cannot work full-time with the development team. They may feel that providing the requirements was enough of a contribution and so may be reluctant to get involved in the testing process. So in terms of test case description for dose checking, so we're going back to that similar example that we mentioned before. So here are some of the specifics that might be considered for dose checking. You have the inputs, you have what are the outputs that would be performed, and then finally you have the tests that would be performed, and then you have the outputs of what's going to come out of that when you're doing that dose checking. Test automation. So test automation means that tests are written as executable components before the task is implemented. So these testing components should be standalone, should simulate the submission of input to be tested, and should check that the results meet the output specification. An automated test framework is a system that makes it easy to write executable tests and submit a set of tests for execution. As testing is automated, there is always a set of tests that can be quickly and easily executed. Whenever any functionality is added to the system, the test can be run and problems that the new code has introduced can be caught immediately. So what about problems with test first development? Programmers prefer programming to testing, and sometimes they take shortcuts when writing tests. For example, they may write incomplete tests that do not check for all the possible exceptions that may occur. Maybe they didn't even conceive of all the possible things that might need to be tested. So some tests can be very difficult to write incrementally. For example, in a complex user interface, it is often difficult to write unit tests for the code that implements the display logic and workflow between screens. So it is difficult to judge the completeness of a set of tests. Although you may have a lot of system tests, your test set may not be providing complete coverage. Well, what about pair programming? Pair programming involves programmers working as a team of two developing code together. This helps developing common ownership of code and spreads knowledge across a team. It serves as an informal review process as each line of code is looked at by more than one person. It encourages refactoring as the whole team can benefit from improving the code system. In pair programming, programmers sit together at the same computer to develop the software. Pairs are created dynamically, so all team members work with each other during the development process. The sharing of knowledge that happens during the pair programming is very important as it reduces the overall risk to a project when team members leave. Pair programming is not necessarily inefficient, and there is some evidence that suggests that pair working together is more efficient than two programmers working separately. Maybe that might appear to be counterintuitive. So let's talk about Agile program management. The principal responsibility of software project managers is to manage this project so that the software is delivered on time and within the planned budget for the project. The standard approach for project management is plan-driven. Managers draw up plans for the project showing what should be delivered, when it should be delivered, and who will work on the development of the project deliverables. Agile project management, on the other hand, requires a different approach, which is adapted to incremental development of the practices used in Agile methods. Scrum is another area. Scrum is an Agile method that focuses on managing iterative development rather than specific Agile practices. And so there are three phases in Scrum. The initial phase is an outline planning phase where you establish the general objectives for the project and design the software architecture. This is followed by a series of sprint cycles where each cycle develops an increment of the system. And finally, the project closer phase wraps up the project, completes required documentation such as system help frames and user manuals, and assesses the lessons learned from the project. So here is a summary of the Scrum terminology. I won't read these in detail. You can feel free to spend some more time on these charts, but you want to be thinking in terms of the development team, want to be providing potentially shippable product increments. You want to be thinking about that, considering the product backlog and the product owner. So these are all things that you want to make sure that you have a clear definition of who they are and what they do. And continuing on, so Scrum, a daily meeting of the Scrum team that provides progress and priorities. The Scrum Master is responsible for ensuring the Scrum process is followed. A sprint is a development iteration. And finally, velocity. This is an estimate of how much product backlog effort that a team can cover in a single sprint. So here is a picture of a Scrum sprint cycle. And so you have, you want to be reviewing the work to be done, and then you consider the product backlog, you select the item, and then you plan. Then you go into the, once again, you thinking in terms of a backlog, and here we're thinking about the sprint backlog. You do the sprint, and then you review the sprint, and then you can go back. And so if you finish a sprint and you think that there could be some potentially shippable software, and that would be a good off-ramp for what you would release. So sprints are usually fixed lengths, say normally 2 to 4 weeks. The starting point for planning is as a product backlog, which is the list of work to be done on the project. The selection phase involves all of the project team who work with the customer to select the features and functionality from the product backlog to be developed during the sprint. And so then we have the sprint cycle. Once these are agreed, that the team organizes themselves to develop the software. During this stage, the team is isolated from the customer and the organization, with all communication channeled through the so-called Scrum Master, the leader of the Scrum. The role of the Scrum Master is to protect the development team from external distractions. At the end of the sprint, the work done is reviewed and presented to the stakeholders. The next sprint cycle then begins, and then you go back to the start of the process. So the Scrum Master is a facilitator who arranges daily meetings, tracks the backlog of the work to be done, records decision, measures progress against the backlog, and communicates with customers and maintains out management and communicates with customers and management outside of the team. The whole team attends short daily meetings or scrums where all team members share information, describe their progress since the last meeting, problems that have arisen, and what is planned for the following day. This means that everyone on the team knows what is going on, and if problems arise, can replan short-term work to cope with them. So what are the benefits of Scrum? The product is broken down into a set of manageable and understandable chunks. Unstable requirements do not hold up progress. The whole team has visibility of everything and constantly There's plenty of team communication, and communication is improved. Customers see on-time delivery of increments, can gain feedback on how the product is working, and trust between the customer and the developers is established, and a positive culture is created in which everyone expects the project to succeed. So here is a graphic that just shows a distributed Scrum. And so you have the Scrum Master, should be located with a development team so that he or she is aware of every problem. You have the product owner who should visit the developers and try to establish a good working relationship with them. It is essential that they trust each other. And you have real-time communication between team members and informal communication, particularly instant messaging and video calling. Great ways that we now have in terms of ways of communicating now. You want to have continuous integration so that all team members can be aware of the state of the product at any time. There needs to be a common development environment for all teams so you can easily have things map into the same environment. And finally, having the ability to have video conferencing between the product owner and the development team. So let's now talk about scaling Agile methods. And so Agile methods have proven to be successful for small and medium-sized products that can be developed by a small co-located team. It is sometimes argued that the success of these methods comes because of the improved communication which is possible when everyone is working together. Scaling up, Agile methods involve changing these to cope with longer projects where there are multiple development teams perhaps working in different locations. And so what about scaling out and scaling up? Scaling up is concerned with using Agile methods for developing large software systems that cannot be developed by small teams. Scaling out, on the other hand, is concerned with how Agile methods can be introduced across a large organization with many years of software development experience. When scaling Agile methods is important to maintain Agile fundamentals, flexible planning, frequent system releases, continuous integration, test-driven development, and good communications. All of those are going to be important things to ensure. So what are the practical problems with Agile methods? The informality of Agile development is incompatible with a legal approach to contract definition that is commonly used in large companies. Agile methods are most appropriate for new software development rather than software maintenance, yet the majority of software costs in large companies come from maintaining their existing software systems. So keep that in mind. Agile methods are designed for small co-located teams, yet much software development now involves worldwide distributed teams. What about contractual issue? Most software contracts for custom systems are based around a specification which sets out what has to be implemented by the system developer for the system customer. However, this precludes interleaving specifications and development, as the norm is Agile development. A contract that pays for developers' time rather than functionality is required. However, this is seen as a high risk. In many legal departments is seen by high risk by many legal departments because what has to be delivered cannot be guaranteed. So it's a level of effort type of a contract. Agile methods and software maintenance, well, for most organizations, spend more on maintaining existing software than they do on new software development. So Agile methods are to be successful, they have to support maintenance as well as the original development. So there's two keys: are the systems that are developed using an Agile approach, maintainability, given the emphasis in the development process of minimizing formal documentation. Can Agile methods be used effectively for evolving a system in response to customer change requests? So these problems may arise if the original development team cannot be maintained. In terms of Agile maintenance, the key problems are lack of product documentation, keeping customers involved in the development process, and maintaining the continuity of the development team. Agile development relies on the development team knowledge and understanding what has to be done. For long lifetime system, this is a real problem, as original developers will not always work on the system and migrate to other projects or other companies. What about agile and plan-driven methods? Most projects include elements of plan-driven and agile processes. Deciding on the balance depends on is important to have a very detailed specification and design before moving to implementation. If so, you probably need to use a plan-driven approach. If an incremental delivery strategy is to be used, where you deliver the software to customers and get rapid feedback from them, is that realistic? If so, you might want to consider the agile method. However, how large is the system that is being developed? Agile methods are most effective when the system can be developed with a small co-located team who can't communicate informally. This may not be possible for large systems that require large development, development teams. So a plan-driven approach may have to be used in that case. In terms of the agile principles and organizational practices, I won't read these, but you need to ensure that you have customer involvement. You need to have the ability to be able to prioritize and embrace change. And you need to be able to have incremental delivery and see how you can do rapid iterations in short periods of time. You want to be able to maintain simplicity. Under pressure, simplicity is going to be your friend. You want to be focusing on people and not process. The people are what are actually developing the codes. And so the individual team members are important, and trying to work that out. So what are agile and plan-based factors? So you can think in terms of, well, here you can be having a system, and so you can have some of the things that are to be defining that. What type of system? What are the lifetime? What are the scales and regulations that are associated with that system? In terms of a team, what is the distribution, the competence, and the technology that team has? And finally, what about the organization? That you have to be thinking of the culture, the contracts, and the delivery. All of those are going to be affecting what you would be experiencing in the organization. So what about system issues? How large is the system being developed? Agile methods are good for a smaller type of system developments where you can have lots of informal communication. What type of system is being developed? And systems that require a lot of analysis before an implementation need a fairly detailed design to carry out this analysis. What is the expected system lifetime? Long lifetime systems require documentation so that you can continue to maintain it. And finally, is the system subject to external regulation? If the system is regulated, you'll probably be required to produce detailed documentation for safety and safety reasons. In terms of the people and teams, how good are the designers and programmers in the development teams? It is sometimes argued that agile methods require a higher skill level than plan-based approaches in which programmers simply translate into a detailed code design. What is the development team? How is a development team organized? Design documents may be required if the team is distributed. What support technologies are available? What kind of integrated development environment do you have? Does it have support for visualization and program analysis? This will be essential if design documentation is not available. Organizational issues, traditional engineering organizations have a culture of plan-based development as the norm in engineering. Is the standard organizational practices develop a detailed system specification? Will customer representatives be available to provide feedback of system increments? Can informal agile developments fit into the organizational culture of detailed documentation? So these are the kind of questions that you would have to be thinking if you wanted to consider embracing agile development. What about agile methods for large systems? Large systems are usually collections of separate communicating systems where separate teams develop each system. Frequently, these systems are working in different places, sometimes in different time zones. Large systems are brownfield systems. That is, they include and interact with a number of existing systems. It's not just a green field all by yourself. Many of the system requirements are concerned with the interaction, and so it doesn't really lend itself to flexibility and incremental development. Where several systems are integrated to create a system, a significant fraction of the development is concerned with system configuration rather than the original code development. In terms of large system development, thinking about this, the large systems and their development process are often constrained by external rules and regulations. So that limits what the way and how you can be doing development. Large systems have a long procurement and development time. It is difficult to maintain coherent teams who know about the system over that period, as inevitably people move on to other jobs and projects. Large systems usually have a diverse set of stakeholders. It is practically impossible to involve all these different stakeholders into the development process. So here is a picture of the factors that are involved in a large system. You have to be thinking of systems, one depends on another, that you don't have greenfield development, so you have legacy things that are involved. There could be a variety of diverse stakeholders with maybe some different points of views, and you have to figure out how to deal with that. There's a regulatory constraints. If you're having a lot of regulation, that can make impacts on how you're going to be developing your software. There's a system configuration of how you're going to configure your system and things that are done the way your culture, your company, the organization does things. And what about if there's prolonged procurement, that there's a legacy maintenance role that can also have an impact on your large software development. So this is a picture of what's IBM development in terms of their agility at scale model. And so I won't go over this in detail, but in the you can see at the outer point, there's agility at scale. The next level would be disciplined agility delivery. And finally, the core agile development, which is the value-driven lifecycle self-organizing team focused on construction. And so you can be thinking about how you might fit into this. And if you're a distributed team, maybe this outer circle is what where you would fit, and maybe agility just as quite as good of a match. What about scaling up to large systems? A completely incremental approach to requirement engineering is impossible. That would be something you might have to deal with. There cannot be a single product owner or customer representative. For large system development, it's not possible to focus only on the code of the system. Cross-team communication mechanisms have to be designed and used, and the continuous integration is practically impossible. However, it is essential to maintain frequent system builds and regular releases of the system. So for multiple team scrums, you can be thinking in terms of role replication, product architects, release alignment, and scrum of scrums. Maybe having this scrum master of the scrums might be something that you could be leveraged. So each team has a product owner for the work component of Scrum Master. And then for the product architects, each of these teams choose a product architect. These architects collaborate, design, involve the overall system architecture. You need to be thinking in terms of a release alignment, that the dates of product releases from each team are aligned so that the demonstrable and complete system is produced. And finally, the Scrum of Scrums, there was a daily Scrum of Scrums where representatives from each team meets to discuss the progress plan, work to be done. So Agile methods across organizations. Project managers who do not have experience in Agile methods may be reluctant to accept the risk of a new approach. Large organizations often have quality procedures and standards that all projects are expected to follow. And because of their bureaucratic nature, these are likely to be incompatible with Agile methods. Agile methods seem to work best when team members have a reliable, relatively high skill level. However, with large organizations, they're likely to be a wide range of skills and abilities. There may be cultural resistance to agile methods, especially in those organizations that have a long history of using conventional system engineering processes. So just a couple charts to finish up in terms of the key points. So in this chapter, we talked about agile methods, and agile methods are incremental development methods that are focused on rapid software development, frequent releases of the software, reducing process overhead by minimizing documentation, and producing high quality code. And so the agile methods include user stories for system specification, frequent releases of the software, continuous software improvement, having a test-first development approach, and having a customer participation in the development team. And then finally, Scrum is an agile method that provides a project management framework. It is centered around a set of sprints, which are fixed time periods where a system increment is developed. Many practical development methods are a mixture of plan-based and agile developments. And finally, scaling agile methods for large systems is difficult. And we walk through that. Large systems need upfront and some documentation or organizational practice may conflict with the informality of agile approaches. Well, thank you very much. We've finished up another chapter and we'll call it a day for this. Thank you.